Hey guys, Jake here, coming at you with another math lesson today. I know it's been a while, been a bit busy working on a little bit something different. Actually recently published my first book, The Elite Guide to AP Calculus AB. It's available on Amazon now. Check out the QR code in the upper right hand corner of your screen. You can scan that to go get a copy of it. Order it on Amazon. You can get it, through Prime. It'll be there in a day or two. So go check that out. But what I'm going to be doing over the next several weeks, maybe months on my channel probably, is going through a lot of the different topics and practice problems that are covered in my book that I recently published. So we're going to kind of start from the beginning and go through it all. So if you're taking AP Calculus AB, this is the place to be. We're going to be going through everything you're going to need to know for the exam coming up in May. So yeah, we're just going to start from the beginning here with limits. So we're going to go through this problem here. We're going to analyze how the function f of x equals x squared minus 4 all over x minus 2 behaves around the point x equals 2. And we're going to kind of approach this in two different ways. So this shows up in my book in kind of the very, very beginning, talking about limits, where we're kind of talking about limits in not really the mathematical solve it type of way, but the more basic kind of what does a limit mean and how do we kind of estimate what a limit might be. So we're going to use this function as an example, looking around the point x equals 2, and we're going to talk about how you can oftentimes use x values around that with the function to estimate what that limit would look like or probably looks like. This isn't the most precise way, but this is kind of the way that limits are typically introduced when you're first learning about them. So keep in mind that a limit doesn't really care what's going on at this point x equals 2, right? It really doesn't. What this function is at x equals 2 is irrelevant. It does not matter at all when you're talking about limits. With limits, you're really looking at the behavior around that point. So the idea there is if we really only care about the behavior around that point, we're essentially looking at values near 2. So what you'll oftentimes see is evaluating a few different x values that are somewhat close to this x value of 2. So kind of the way you oftentimes see this written out is you'll see kind of a little table basically where you have x values and then whatever the value of f of x is at that point. And then we're going to put in x values that kind of circle around 2 and get closer and closer to 2. So we don't actually want to put x equals 2 in here. Instead, we'll put x equals 1.9, x equals 2.1, and then, we need those to actually be the furthest points away. So we'll actually start even a little further away. We'll start at 1 and 3, and then we'll kind of step in closer from there. So we'll go 1.9, 1.99, 1.9, 9, and actually I'm going to need to stretch this out a little bit. Then we'll get points that are a little bit bigger than 2, but super, super close to it. So 2.001, 2.01, 2.1, and 3. And so with limits, you're kind of starting at the further away points, the 1 and the 3, and kind of working your way in towards 2. So 2 obviously would be kind of between 1.999 and 2.001. Again, we don't really care what's going on at 2. We care about what's going on kind of at these points around it. So if we plug in x equals 1, for example, we get 1 squared minus 4 all over 1 minus 2, which would be 1 minus 4, which is negative 3. 1 minus 2 is negative 1, so that gives us 3. And then, so that'll give us our f of x value of 3 here when x equals 1. Same idea, we can plug in when x equals 3. We'd get 3 squared minus 4 over 3 minus 2, which would give us 9 minus 4, which of course, would just be 5, and then 3 minus 2 is 1, so that gives us 5. So we get 5 right here. So I'm not going to go through actually, plugging all these in, but if we plug in 1.9, 1.99, 1.999, and then same thing with these values here, I'll just kind of skip to what those values end up being. We actually would get 3.9, 3.99, 3.999 as our outputs. And then for these values, we would get 5, of course, for x equals 3. And then for x equals 2.1, we get 4.1. For x equals 2.01, we get 4.01. And then for 2.001, we get 4.001. So you can see as we kind of move in towards x equals 2 from both the left and the right side, we're approaching, our output is kind of closing in on y equals 4. So we can kind of see that these values are getting closer and closer to 4 as our x values get closer and closer to 2 from both the left and the right side. So what that tells us is this limit, the limit as x approaches 2 of this f of x here, is probably going to be 4. Now, if we wanted to get a little bit more precise and actually solve that, like I said, this is kind of the estimate, the rough estimate way to find a limit, or to get a good idea of what the limit probably is. If we wanted to actually solve the limit in this case, though, let's talk about how to do that real quick. I'll actually put this in a different color. Let's go with kind of this light blue here. We'll say the limit as x goes to 2 of this function, x squared minus 4 all over x minus 2. If we wanted to actually find this limit, we of course, usually the way to start with trying to find a limit is to just imagine what do you get if you plug this x value into this function. Well, if we do that in this case, we actually get undefined, because we get 2 squared is 4 minus 4 is 0 over 2 minus 2 is 0. So we get 0 over 0 if we just plug it in, which is undefined. So we have to try something different. Well, in this case, this fraction can actually be factored. So this is actually the same as the limit as x approaches 2 of x squared minus 4 is a difference of squares. Difference of squares is when you have a squared term minus another squared term. That always factors out into so if you have a squared minus b squared, that factors out into a minus b times a plus b. So that would give us x minus 2 times x plus 2 all over x minus 2. So in this case, the x minus 2 term on the bottom will cancel with the x minus 2 term on the top. So this should be equivalent to the limit as x approaches 2 of x plus 2. Which now, if we just plug in x equals 2, we get 2 plus 2 is 4. So you can see solving it the more precise way actually got us the same thing we got from doing this kind of rough estimate by plugging in x values around 2. So that's pretty much the concept there. So hopefully you found this video helpful. If you did, be sure to give this video a thumbs up for me, and go check out my book, The Elite Guide to AP Calculus AB. Scan the QR code in the upper right hand corner, or click the link down below to go check it out. Thanks, and I'll see you next time.